Welcome to the Thoughtful Software Podcast. My name is Fahad Shoukat, and my co-host is Andrew Wolfe, CEO of Skiplist. So we believe thoughtful people and thoughtful software will change the world for the better. And so this podcast is all about just that. As we dive into new technology, we discuss industry trends, but more importantly, we help people be better at what they do. And this is the focus of what we call thoughtful software. So in this episode, we spoke with Mike Jones, VP of Engineering at MedaSync. MedaSync is a centralized case management system, and their software helps monitor care and services. It instantly flags anomalies and alerts teams to reimbursement opportunities that are typically missed. And so MedaSync is transitioning to a full serverless framework. So we discuss what is serverless technology, why it is important to application development, some of the benefits and challenges, how to implement a serverless framework, and many other areas. It is a bit more technical than normal, but I really enjoyed this conversation, and I'm sure you will also. So here's Mike leading us off. Here we go.
So my name is Mike Jones. I'm a full stack web developer. I've been working in Cleveland for about 5 years. I've sort of been in and out of the startup space here. My first taste of it was in 2013, 2014 at a company called Socrates Analytics. From there, I moved on and worked with Andrew together at OnShift. I was there for about 3 years. We overlapped for about 2 of those, doing some really cool things there. Both of those shops were full stack web with Python frameworks, mostly Django and Flask. With single page apps on the front end, so React.js. So that's kind of gives you a little bit of a taste of the tech, and then a SQL database for both of those companies. Ryan, so in terms of MedaSync, Ryan approached me. He said, "Hey, we see some parallels between what you did at Socrates and what we're trying to do, because the customer is similar. It's a skilled nursing facility customer, and the problem that we're trying to solve for them is around reimbursement." So when a patient is admitted to a skilled nursing facility, they are on an insurance plan, and that plan has different levels that determine how much money that the SNF gets for the patient to care for them each day. And that's based on their acuity, how much care they're going to need. So let's say a patient needs medications from an IV bag more than twice a day, for example, that might set a reimbursement level. Or if they need 150 minutes of therapy a week, that might set a particular reimbursement level. And so that's agreed upon out front. And so let's say the patient's on Aetna insurance, they might be at Aetna level 2. Now let's say they get to the facility and it turns out, we're actually providing them 200 minutes of therapy a week, and they really should be reimbursing us at a higher level. They don't have a good system for A, realizing that, having that information bubble up to them, and B, reaching out to and notifying the insurance provider that, hey, you should be reimbursing us more because we're having to provide more care for this patient than we originally thought or you originally told us.
Why don't we start off, and you can kind of jump into what's your interest in serverless technology, and like what is it actually, and maybe also why you're considering to move all full serverless.
Sure. So when I got so I think it's important with anything like this to kind of approach it from the angle of what problem does this solve. And I can kind of speak to a couple specifically with respect to MedaSync. So first of all, with MedaSync, it's a lot of ETL jobs. It's a lot of data pipelines. So we pull in data mostly from electronic medical record systems, so point-click care. And so it's not real time, but we do run data feeds from point-click care multiple times a day. And the problem with making that scale is that say you bring on, if we really blow up and we're pretty early stage at this point, but I have to prepare for the fact that, okay, Ryan's got this really deep sales pipeline. We need to be able to know that we can ramp up, dozens and dozens of customers, and know that the boxes that feed this data into our database are not going to fall over. We need a plan to make that scale and not have to take a bunch of time every time we bring on a new, round of customers, to plan for, okay, how are we not going to have our application fall down the moment we turn these data feeds on? So that the first thing is really scalability. The other thing is just like the event-driven monitoring. So the ability to scale those resources up and down, because we don't need these ETL boxes to run, at full speed 24 hours a day, right? We run these a couple times a day. We really just need these bursts of computing power to get our work done. And what things like AWS Lambdas and especially organizing things with asynchronous queues and events allow us to do is only use the exact amount of computing power that we need. Let these, functions as a service spin up, do the work that we need them to do, and then spin that back down. And so I think those are the two big advantages for us are cost savings that come from only using the computing power you need and just being confident and knowing that we have a pretty easy to understand stack that's going to scale well.
Yeah, so you're talking about like auto scaling and then like just paper execution. You're not paying for any idle time. And that's specifically, is that what you call like a function as a service? Like is that what AWS Lambda is?
So Lambda is basically AWS's functions as a service offering. And so just to give you a taste of kind of what our ETL kind of pipeline looks like, we basically say, okay, at this, we have, scheduled jobs. You can schedule Lambdas to run based on a number of different events. You can say, okay, I want this function to run at 2 a.m. every morning, or, when a new file gets added to this S3 bucket, I want to kick off a Lambda to process it, things like that. And so it gets rid of a lot of the, synchronous polling, like, okay, I need to just sit here idle until something's ready for me to work on. And now I know that you can do that. You can use things like Kubernetes and ECS auto scaling to accomplish a lot of the same things, but it just requires more basically know-how and also a little bit more effort to deploy things. So what I like about not just serverless, but the serverless framework in particular, it kind of combines the nice things about infrastructure as code. So AWS's infrastructure as code offering is CloudFormation with deploying your Lambdas, your code on those resources at the same time. And so we can basically say, okay, within this ETL project, we have these S3 buckets for all of our files. We have these Lambdas to process them. We have these databases that we want all of the results to end up in. And we just have all of that described in a simple, JSON or YAML document. And we can basically just push deploy and deploy as many instances of that, little component as we need to, and be confident that it's going to work the same way as many times as we need to deploy it, as many environments as we need it to be in.
So if I'm a CIO or CTO, I've been one of those before. I've went through the virtual machine thing where everyone's like, oh, you got to go virtual. And there's good benefits for that. So I went about VMware. And then all of a sudden containers were the next big thing. And I just got my containers in there. Maybe I'm thinking about Kubernetes right now if I'm an enterprise CIO or CTO. But now serverless is out there and I'm freaking out because I've just spent so much money on containers. And I might be already dedicated to millions of dollars in my budget towards getting a Kubernetes installed if I'm not using managed Kubernetes. In some cases you can't because you have your own data center. Like what would you tell those CIOs, CTOs? Like what should they look at and say, okay, I can use containers for this, and for this I should use serverless? And how would you make serverless into the current rollout of container strategies at a lot of these enterprises and some startups too?
That's a good question. So I would say first of all, don't panic. I think that Kubernetes is still a very viable technology. It still solves a lot of the same problems that I talked about, if done well. And another thing too is you're right when you say that serverless is still pretty new. A lot of the really top-notch people, particularly in the Midwest, Kubernetes is their bread and butter. They're going to be able to stand up a working stack on something like Kubernetes just faster and better, at least maybe out of the gate, than serverless. Now, in my case, I almost benefited from a certain degree of inexperience because I basically, for me, this is my first go at this, and it's funny when you mention managed Kubernetes because with this serverless, with the serverless functions as a service stack, AWS is sort of catering in the other direction with AWS Outposts because there's been some outcry. It's like to develop on this stack, it's important for a developer to be able to run the whole stack on their local machine, and for testing too, it's important to be able to stand it up. Maybe not in a fully managed AWS environment to be able to do specific kinds of end-to-end testing, or even just run integration tests against the database in your continuous integration environment without having to talk to a managed thing in AWS. So there are advantages and disadvantages to both. And also there are some things, and I think it's important to address certain weaknesses in whatever technology you choose. There are certain things that you simply can't do with a Lambda. So there are specific types of queues, for example, that you can't use a Lambda to listen to. So to give you to not get too down in the weeds, but a first in first out queue, you cannot have a Lambda listen to that. And we need to use first in first out queues because we need to be assured that certain jobs run exactly once. And to keep very strict track of that. And so for those, we have to actually use a containerized solution. We use ECS for that to spin up and pull those queues. So we can't use there's some certain things that you simply can't use fully managed functions as a service tools for. Another example would be anything you have that has specific dependencies on the operating system. So like if you wanted to take like an open source technology that maybe takes more than 5 minutes to run or is very memory intensive and run that as a web service, Lambdas really aren't an option for you because you're capped at a max of 5 minutes of runtime and your memory limits are pretty low. So in those cases, you pretty much have no choice but to use a container. So and a third use case I'll mention that maybe you'd want to consider still using containers would just be, and I think this is something that you and I have talked about before, Andrew, is real time. So when you have functions as a service, there's a certain amount of latency around spinning that environment up to run your function. It may only be, a few milliseconds, but for a company like, Bloomberg, say, that needs to do, get these to do like real time to the millisecond, trade execution or things like that. I don't know that just a vanilla serverless architecture would be an option for that.
Obviously serverless from a Lambda perspective is really interesting. Just dynamic compute in general. You see that people trying to reduce cloud costs, right? You actually see cloud costs ballooning because people have these very large servers running 24 hours a day. I think serverless is a great answer to offload a lot of that and not have as much what we'll call static compute, which is just, I don't have users at 1 a.m. Why? Because we run business applications and no one's working at 1 a.m. So why can't I just have, pay for what I use?
Absolutely. And I think in a lot of those cases, introducing some of the depending on the sophistication of the container solution you're using to run that, introducing that, extra complexity to do the spin up and then spin down, that may introduce, points of failure depending on the level of expertise at your shop. And I totally acknowledge, it's possible to be really sophisticated about scaling containers up and down. What appeals to me about it is just how just automatic it is, how it just works. That there's not a lot of configuration that I have to do, that as long as I'm using, API gateway with Lambdas listening to it, it's going to spin up, do its thing, and spin back down without me really having to configure much of anything.
So one thing that's really exciting for me, having managed databases a lot in my career, if you end up just having the mentality of doing the dirty work is almost always database management.
Yes.
And so the cool thing about like DynamoDB, you see equivalent offerings in Google, equivalent offers like Spanner. These, what they're calling NewSQL, and I don't know if I necessarily like that terminology, but this whole idea of this globally distributed, eventually consistent database that scales up to whatever need, terabytes, petabytes of data, while also providing some SLA guarantees, is really cool. And that's the part of serverless I'm really excited about, because we're moving that demand for database management. If you're a CIO or CTO, you probably spend or have 2 or 3 DBAs. They're expensive, $140,000, $150,000 a year employee if they're really good. Not getting rid of them, but moving that management cost to the cloud. NewSQL, Spanner is incredibly expensive, but when you really think of the cost of management, of having a solution that manages itself, you probably save money across the year. I know you're using DynamoDB. How's your experience been with that?
Good question. And I think you're absolutely right that it is, you refer to it as the dirty work. That's definitely been the most brain power intensive part of trying to design this, is trying to understand, okay, how should I organize this data for this specific use case? And so, like you kind of alluded to, it's all trade-offs, right? yeah, ACID compliant transactions are awesome and very important and necessary in a lot of cases, but it makes certain operations expensive and not very scalable. Another thing that a lot of SQL proponents like about it is like the flexibility and the querying power. It'll let you, with a pretty small amount of code, write a pretty, rich, complex query. But again, often at the expense of performance. If you want to join 4 or 5 tables together, that's going to take a very long time.
Just for the listeners, Mike, ACID compliance is usually related to SQL relational databases, and those are some guarantees you get, like atomicity, consistency, isolation, and blanking on the D.
That's okay.
Serverless.
So I'll just share. Why don't I share like the classic like undergrad example? So Andrew, let's say that you and I, we're in a business together and we have a shared bank account, and it has $100 in it, and we both need to withdraw money from that for whatever reason. And so when we both want to withdraw $60, and let's say we're both at 2 different ATMs, and we both, do our thing at the exact same moment, like to the millisecond, the exact same time. If you don't have transactions, what would happen is both of our $60 withdrawals would be allowed to happen, and there would be no overdraw warning, because the database would do the read. It would say, and for both of us, and it would say, oh, there's $100 in this account. That's enough money to cover this withdrawal, and it would allow us both to do the operation. So that's like database transactions 101. If you have 2 writes happening at the same time, you can have things that shouldn't happen happening in your database.
Correct. And transactions and relational databases prevent that from happening, whereas in NoSQL, there's not that same guarantee, because it's eventually consistent and not completely consistent because of the transactions. I just want to make sure that, all right, now we can continue going back up the stack.
That was important. I'm glad that you took a pause to kind of lay that down. I would hate to, use a confusing acronym without explaining
but
it.
That's all good, because DynamoDB, right, is NoSQL. It's not necessarily new SQL, but it's it doesn't have that eventual consistency, but the reads and writes are incredibly fast. I think they have an SLA on both, which, if you look at like relational solutions, even managed relational solutions, they don't really give you an SLA on writes, because, it depends on how you index the data and all of that can affect your write speed. But Dynamo doesn't have that same restriction.
Right. And so to back up a second, I'll preface this by saying, Andrew, you probably have a lot more database experience than I do. Basically, the reason that I chose Dynamo is because, number one, it is fully managed. I don't have to worry about database servers or RDMS instances to run a Dynamo database. And the other thing that you just kind of alluded to is it scales really well. There are basically 2 knobs to control the performance. It's the read capacity and the write capacity. And I basically, if I need to, really turn up the performance of this thing to handle additional load, I basically just have to turn up those 2 numbers. And so it's really straightforward for kind of a novice to database management like me to come in and say, okay, I understand how I'm going to scale this thing out when we bring on a bunch of new customers. Now, the trade-off is, like you kind of mentioned, this ACID compliance and transactions. But luckily, there are patterns and strategies that Amazon recommends to handle that. Actually, back in November, around, I think, reInvent time, which is their big conference every year, they rolled out transactional writes, very small. I think you can write up to about 10 records as part of an all or nothing ACID compliant transaction, which is pretty cool. Now, 10 items, of course, SQL will pretty much let you do anything as part of a transaction, no matter what the size. But the fact that they're starting to cater to that use case kind of says to me, okay, they're acknowledging that there's some give and take, and I'm kind of excited to see. I hope that we can see, the SQL and NoSQL worlds kind of meet in the middle, and converge on a pretty good solution. But I think the
promise of new SQL, right, is we can do both, because we can have our cake and eat it too.
Yeah, and to be clear too, I didn't choose NoSQL because there's no schema or structure, and you can pretty much throw whatever you want in there. And so a lot of my time up front has been kind of deciding, okay, how should we organize our data so that, we can still, if we have to add new types of data, we're doing that in an organized way that doesn't cause a bunch of problems, for other data that we have stored, and so that we don't have, let's say, three different ways of structuring a patient record, and now our application code has to account for that. That's just way too much complexity for me to even fathom. So I think it's worth taking the time up front to make those, schema and structure and architecture decisions, which SQL does a lot of that for you, basically. And so that's kind of the trade-off that we took at MedaSync, and kind of decided that was worth doing.
And so you have this fully managed stack that's almost auto-scaling. I mean, you might have to log into a UI once a month and adjust some numbers because you're B2B and you onboard a customer. So you go in and at 100 to your read and write capacity, and then you go to sleep. So being fully managed, right, is nice. Because you don't have to worry about a lot of things. But have you run into any pitfalls where, you wish you could manage your own database? Or I doubt yet, but do you see any pitfalls coming up soon where that fully managed doesn't necessarily work for you, with maybe complex, something you'd like to do with the database, but you can't because Amazon won't let you, for example?
So that's a good question. It's I'll be honest, it's a little bit early to say. I'm kind of closing in on the end of this, schema design and data access pattern design phase, where I'm just going to start to do some load testing. And first of all, our CEO has been very patient with me as I learn about this tech, which has been awesome. But I think that we need to be careful because this is unfamiliar to me and to a lot of people that jump in and want to use it. You need to be very, very careful and be aware of the things that we just talked about. The fact, the things that you more or less get quote unquote for free with SQL, like a schema, you basically, unless you're going to use, unstructured like JSON columns for everything, you need to decide how your data is going to be organized up front. And I think you need, I think choosing to, apply that discipline to ourselves and not let it be the Wild West so that we can roll this out fast and then tie ourselves in a knot later when we have to try to make changes to it. So I think that's probably my biggest concern is, getting this thing ramped up and then realizing, oh no, we got ourselves into a corner with the way that we organize this. But the nice thing is, because it's easy to deploy things, to deploy other instances, we can ramp, like probably what my fallback would be if that happened would be, okay, fix the problem, slowly work toward fixing it for additional customers. But while that happens, add new customers to the new version of the database that has this problem solved, and then slowly migrate people over. So it's not like a showstopper. It's not, wouldn't result in downtime. It's just kind of the natural things that come with trying a new technology.
Yeah, I actually had a question around that because I was curious, like if you are going full serverless and you're relying heavily on AWS or even let's say Okta or something like that, and that goes down, you may not have the resources to, can you just easily spin something else up or, debug it? Do you find challenges in that? Like you're just basically using other providers?
So the nice thing is, AWS does. Are you asking specifically like what if there was a big like AWS outage in our region?
Yeah, and you're leveraging just other providers in the serverless framework, right? And what if some of them that's very critical to your function or to your application goes down?
Yeah, and so right, and so I think that the biggest thing with respect to that would be the data, right? And so there are strategies, and so that's why like backups and replication are very important, and that's something that we've thought about. So for example, for Dynamo, because that would be the critical thing, right? If your data is inaccessible, that's a showstopper. That's a huge problem. To be honest, that's a problem that I have a rough idea of how to address, but it's something that we've kind of put off solving right this moment until we've grown and have a slightly larger customer base. I know that there are ways to just kind of spitballing how I think I would do it would be, deploy our web application service to multiple different regions, and kind of allow the front end to fall back to the other one if things fail. As far as like replicating data across regions in real time, I would need to learn more about Dynamo to know how to do that. What we do have is point in time recovery. So basically, every so often, Dynamo will store a backup of our whole database, And, let's say, and if we have downtime, or, if we have a migration that gets screwed up or something, we can always, it takes time. This might result in a little bit of downtime, but we can restore the database to exactly the way it was, 24 hours ago or something, and then rerun any ETL that we would need to. So we have some fail safes, but that's a totally fair point you're making, is that, yeah, we are very reliant and dependent on the provider. We don't host any of our own stuff by design, and so, yeah, it does set up. It does sort of set up AWS as a single point of failure that way. And it is kind of in Bezos we trust. It's like we trust that these big providers are kind of too big to fail. I think if they failed in if whatever. In fact, we were on Azure. Originally we had a monolithic .NET app on Azure, and I think within the first couple weeks that I was there was some natural disaster in the U.S. South Central region, and their data center was down for 8 hours, and that's where our database was hosted. And so, yes, that stuff does happen, and we do need to account for it.
One major concern a lot of people have with using serverless technology, and it's a fair evaluation, is vendor lock-in. So if I'm using Lambda, they have some primitives in there that and how you write your code, and it is slightly different than the way Azure, for example, you brought that, it makes you write the same serverless function. So it's very hard to port your code over one for one. Do you think that in the long run, I don't know, for me, I like negotiating power. And if they know I'm locked in, my entire stack's on Lambda, I don't really have too much negotiation power. I could say, hey, I'll rewrite my entire code base, and they're going to be like, okay, good luck. And that's the end of it, right? They know I'm not going to. What do you say, is that a valid concern? Is it an invalid concern? And if it is a valid concern, how can you mitigate some of that vendor lock-in?
Yeah, so locking into a particular cloud hosting provider, for example.
Yep.
That's kind of what you're talking about. Okay. So I think specifically in the example of Azure, we actually first, before we went ahead with doing so much in AWS, because our application was .NET, looked into Azure's offerings in this space, and we actually have a few small, they call them function apps, Azure function apps, to do specific small things to kind of start to break up our monolith before we kind of decided, no, we're going to go fully over to AWS. The simple things like the programming languages that you can write function apps in are limited. Just the way that they do infrastructure as code with templates is, it's not worse than AWS. It's just different and unfamiliar to me personally. So, the concern you're raising is a valid one, but it's not one that MedaSync has had. Honestly, we are pretty laser focused on our business problems, and we're focusing on architecture to the extent that it allows us to solve these business problems. I think that the broad feature set that AWS offers and the simplicity that it lets me, design CloudFormation templates and design, auth roles and things like that is familiar enough to me. I simply don't have that familiarity with the other providers. Now I know that the serverless framework, one of the big goals of it is to let you write in as much of a provider agnostic way as possible. But the problem is, when you get down to deploying CloudFormation resources, let's say, okay, I want to deploy this new database, and here are the settings that I want. They all sort of have their own way of doing that. And so, while it would be a huge bragging rights thing, right? It would be a huge accomplishment to say, hey, with a push of a button or the change of one configuration, I can deploy this to GCP or AWS or Azure, and it'll work the same way on any of them. That would be an amazing place to get to. Honestly, we're not there yet. We're pretty coupled to AWS.
Yeah, I think that there's definitely some drawbacks, but one thing I found extremely fascinating by this is if you have a fully managed service, it allows developers specifically to kind of now start focusing more on business logic, as you mentioned, right? And to me, that I found fascinating because I harp on this at Skipless all the time. What is the customer experience? How are we building this from the customer perspective, the user perspective? And the more that the business, all the way from developers to, even sales, in less time you're, worrying about architecture, and you can focus on, all right, how does this application actually work? And it's always from a customer perspective. I'm all for that. And I think you can kind of live with some of the drawbacks if you're able to focus more on business logic and making your application a lot better from that perspective.
Yeah, you're absolutely right. And I think too, that was kind of my goal when I started at MedaSync 6 or 7 months ago. I set as one of my goals to have a zero tolerance policy for drudgery. And I considered that like manual, repetitive, error-prone tasks, like deploying software, like having a person, have to run a series of steps to get something deployed, or manually set up a database, or configure a new customer, or configure a new user. It's not an interesting thing to do. I don't think it's what anybody learned how to be a developer hoping that they would get to do. And you're right. I think too, for the business side and for the customer, the more time that developers can spend thinking about edge cases, thinking about what side effects might this have for the user experience, and not, okay, as soon as I'm done with this, I need to spend 3 hours trying to remember how to deploy it, I think is just good for everybody. It makes us happier, and it helps us get work done faster. And like you said, focus on the business problem and not these sort of mundane, really solve problems of deployment and scaling.
One interesting thing too, also I was interested in, what about like the culture within engineering and IT as you move towards a like full serverless framework? I would imagine at bigger organizations, maybe not at MedaSync, you'd have some challenges there that people who may not want to adopt this new kind of framework.
Honestly, that was something that concerned me initially, because I know it was a big departure from the way that they were doing things. I'll credit, I mean, and it's a shop of, it's me and it's 2 other developers right now. We're pretty early stage. I credit Tim and Alejandro, our 2 developers, for the egolessness and the open-mindedness with which they took this on. It was a big change. It was a lot different from the way that they did things. But I think that they acknowledge, like, yeah, we don't like doing these mundane things. I think that they right away understood that the problem that this solves, and I think that we're reaping the benefits now. I think that like maybe the bigger benefit and the bigger piece of our company that allowed this to happen was the buy-in from the business side, the buy-in from the CEO to say, yeah, the only way that we're going to be able to not focus on deployments and scalability is to just solve it up front. Kind of the only way out is through mentality. Just do it right, have it established, and then kind of move on to the interesting business problems that we all want to spend our time solving.
Well, so because we have to increase the value of our podcast, we have to talk about AI, and where does that fit in to all of this? So
I've honestly been specifically the two pieces that we focus on right now are we're actually working, the thing that we're working with Skiplist with, natural language processing, both in terms of just small categorization problems to big multi-page documents, trying to extract like clinical services from those, and the other piece is just pretty simple machine learning. I wasn't really aware before I took this job just how many fully managed tools AWS had rolled out. I was blown away. At this point, it's less about actually understanding what's going on under the hood and more about just learning how to train data and feed it into these managed tools the right way. So specifically, the tools that we use are AWS Comprehend and just AWS machine learning. But that's just the tip of the iceberg in terms of what Amazon offers. And I know GCP and Azure have their own fully managed offerings. I am far from an AI expert, but there's really only one direction to take here in terms of, okay, if I can try to stand something up and deploy it and learn how it works on my own versus read a couple pages about what this fully managed tool does and learn how to feed data into it and be reasonably confident that it's going to solve a specific problem for us, I'm going to take the managed tool every time. It's so enhanced what we can do quickly, given the knowledge that we're starting with. It's a really fun time to be doing this stuff.
So let's come back to one thing I wanted to talk about as you guys were speaking earlier, is when you switch to a serverless framework, what are some tips that you could, maybe share for companies? Maybe it could be something like, don't use old code, or, create, really good reference guides? Do you have any tips on switching to serverless?
Sure. So I think that definitely coupling it with infrastructure as code is really important. Because I think early on when I did it, we were, creating resources like databases and like S3 buckets to store files, things like that. We were creating that in the console and just deploying code to talk to those things. I can't stress enough the importance of using, defining those cloud resources as, specifically in the serverless framework, deploying functions, to Lambdas or functions as a service should always be coupled with code that describes the resources that they're going to need to talk to. Because that's what allows you to, deploy it really, with a push button or a single command as part of a CI/CD pipeline. I think going all in on it, having the whole package of tools is really going to give you the most benefit. The other thing I'll mention too is just, this is a good idea no matter what stack you use, is just testability. Being able to write your code in an isolated, decoupled way so that you can deploy it on its own and not have this, if you have, Andrew, you and I have both seen code like this, where a function, will take maybe 12 or 13 inputs and be 800 lines long. That's bad code no matter how you deploy it. And so there's just really no substitute for well-factored code. And I think it's especially important given the memory and runtime limitations of a Lambda and probably any, fully managed function as a service. But it's especially important just to get this stack to work.
One thing I think we're going to see a lot of, and talk about testability in the next couple of years, is a lot of serverless testing frameworks. I've seen a few recently, but I don't think it's popular enough yet and widely spread enough for anyone to put testing. But the testing paradigm kind of changes a little bit. Where do you test it? There's obviously CI/CD frameworks to help deploy to Lambda and all of that. But testing in isolation and then testing together, it's a little different than testing a monolith or even microservices. But even with microservices, you've seen some testing frameworks that are specific to that architecture. So it'll be interesting to see how the serverless architecture kind of changes some testing frameworks. Like, does Cucumber still work the same way? And it should, because you're using Cucumber to test your front end, but what other frameworks just become invalidated because you can't test the same way as you used to? It'll be very interesting.
Yeah, and I think the hope is for those end-to-end tests, things like Outposts are kind of the promise to allow you to do that, and we'll see if they fulfill that.
Is there anything that's exciting for you in this space? Could be anything around this framework or anything around architecture.
So for me, I'm just excited to over the coming months, the rest of this year, watch as we bring on customers, watch this thing scale up. Just see how well it lines up with our expectations. It's our first time through it. I'm sure there are going to be some things that don't go as well as we expect. But I'm excited to see this thing, kind of in action. And I think too, I'm kind of speaking hopefully and forward looking today. I'll be interested to see, where I'm at in 6 months, when we're really, going full speed ahead with this, and really scaling up, on this tech stack and as a business, how well this stacks it up. And I'm really optimistic and hopeful, just knowing the problems, with monoliths or containers that we're not going to have. I'll just be curious to see how this all shakes out. I'm very optimistic and excited that this was an option for me when building this.
Actually, one question I didn't ask that I wanted to ask: this seems like a technology like for maybe small to medium sized businesses? Do you see large enterprises adopting a serverless framework?
That's a really good question. You're right, because anything simple to do, and really that gets to the green field versus brown field. And you guys asked a question earlier: how would you encourage somebody to switch to this? I think for a large enterprise with a big existing code base, switching to anything is difficult, and it's really business, in a lot of cases, business problem specific. I would just say, kind of Andrew, kind of like conversations that we've seen at other companies we've been at. Try to pick an isolated, container or problem to solve that you can easily kind of decouple and carve out to kind of experiment with this technology. And a large enterprise may not end up using serverless for their whole stack. may only be for a few isolated pieces. I would just say keep an open mind and just pick the right tool for the job. Serverless was the right tool for us, but I have enough healthy skepticism to not see it as a panacea necessarily.
It used to be you were stuck in one single paradigm of how you built your software, and you really couldn't escape that. And now we're seeing so many paradigms just open up, on all fronts of the stack. Single page applications on the front end, the back end, you have containers, you have Kubernetes, you have serverless, and it's just exciting to have options and see how to use those options and continuing to proliferate those options. I'm just so excited about that, especially when it comes to AI and the advances people are making there for managed AI. So, but I'm just pumped. The cloud has been great for everybody.
Yeah, couldn't have said it better myself.
Yeah, I think it's exciting too. Like, for one last point was, as an entrepreneur, just spinning up a startup or teams, you don't necessarily need to find developers that understand, really solid architecture frameworks. You can kind of put a team together and basically hire developers that maybe are more business focused and they can kind of execute the vision rather than maintaining a database. And I see that being a huge benefit to just entrepreneurship and businesses in general.
I'm just, being an entrepreneur for so long, it used to be you needed someone you needed the best architect on the planet to solve some of these problems. And now it's like you can install a good enough computer vision model to get you an MVP. You can grab things off the shelf. Now, those things might not work for an enterprise grade solution, or they might not work for some really advanced use cases like some of our customers have. But in general, getting a startup, the barrier to entry is, can you use a keyboard and can you click a few drop downs in AWS and you can put yourself there.
Thanks for listening. You can always connect with us at skiplist.com.